Hi, this is Mikhail Golovnya, Senior Scientist at Salford Systems. What I'm going to talk about in this video is the powerful facility within SPM that we call SPM Automation. Now this video is somewhat introductory to the whole series of videos that we are going to put together that explore different parts of automation facilities available. Some of them are simple, some of them are a lot more elaborate and more geared towards advanced user. But regardless how you see it, SPM has a very powerful facilities to automate and create collections of many different runs. In terms of our own terminology, we reference all the automated facilities as batteries. Batteries of cart runs, batteries of TreeNet runs, batteries of Mars, batteries of that go across the engines. So every time you see or hear a term battery, what it usually means is that we're talking about packaging a collection of runs where each run is obtained by doing something either to the engine or to the data set that you have available for learning. As you will see, there's a lot of different batteries, but they all can be grouped in several broad categories. At the very bottom, I would say, the foundation will have a fairly simplistic batteries that simply manipulate certain specific control parameters of the engines. So for instance, in the cart tree there is such a control setting as limit on the node size. In the Mars engine you might have the number of basis functions. In the TreeNet engine you could have a control parameter that sets the learn rate, or maybe the number of nodes per tree, or anything that doesn't directly relate it to the data set that you have, but it's strictly a control that influences some internal engine machinery as it tackles your modeling task. And in those situations the battery is pretty simple. So you could say, all right, let's just look at the TreeNet engine and let's try all these different learn rates from a specific list, and then run all of those runs automatically and then package them as one container, and then you can work with those. So those are pretty straightforward, and we are not going to talk about each and every one of those because they are kind of self-explanatory and very easy to handle and address the specific situation. There will be other batteries that are a lot more elaborate, and usually those handle modify your data in some fundamental ways. For example, different sampling techniques, or different battery that explores what happens as the amount of data is progressively eliminated. There will be batteries that have some profound implications. For instance, battery priors that changes the prior probabilities and can be used as a very powerful ensemble. There will be batteries that work with your predictor list, most notably battery shaving, that does essentially variable selection by pursuing some kind of systematic variable elimination techniques. There will be batteries that shift window in your data to explore some time component. The list of batteries is open-ended. We keep on working on it, and each time as time goes on, we are adding additional bits and pieces of automation or enhance and improve upon the existing ones that we already have. So this is a very active area of research and development, and I'm pretty sure you will find many of the videos that are dedicated to one or another specific battery very useful for your individual work. So what I'm going to illustrate here, just as a very beginner level, in general, how easy it is to use the battery machinery. So I have a SPM running here. I'm going to open a data set called SPAMbase, and I use that data set a number of times here and there. It has to do with classifying emails as either spam or no spam based on their word content in terms of bag of words frequencies. So I'm going to open the data set here, 58 variables. I'm going to model it using cart. So I'm going to sort predictors in file order. and the target is my target. All of the remaining variables are my predictors. It's a pretty straightforward setup. It's a classification run. All the usual things. We set, say, 50% of data as a test sample, or it could be 20%, 30%, up to you. And I will also limit some node counts, say 30 cases required for parent nodes and 10 cases required for terminal nodes. And this time, when I click Start, it proceeds and it develops a single card tree, and it's all pretty straightforward. And I'm not trying to explore more of the items here. So I have a single tree, but this single tree is constructed based on whatever predefined settings that you had in your model setup. And one of those settings was under method, the default splitting rule was based on the Gini improvement calculation function, or Gini impurity. Apparently, for classification trees, there are also symmetric Gini entropy, class probability tuning, and order tuning. And each of those ones may produce a somewhat different tree. It also depends on your target. It also depends on the other types, other things in your data set. Now, you can either do it by hand. So you could either say, okay, let's run Gini tree, let's try entropy tree, let's try tuning with power 1 tree. Or you can rely on the mechanism of batteries, card automation, to basically run them all in one big swoop. And that's where the battery tab is located. So there's the list of batteries, and I want you to start reading those descriptions and being kind of more and more comfortable understanding what all the different individual batteries are for, and we will provide a lot of help and a lot of explaining on some of the more elaborate ones. But this one for cart is actually pretty straightforward, and it's called rules. Run every major splitting rule. So all I need to do is click Add, and then click the Start button, and this time the software runs all 6 different card models for me and packages the results in the overall battery results window. Now, what you can see here is there's basically 6 lines. Each represents an individual tree. And each tree was built by varying the splitting rules. So you have a SymGini tree and the Gini tree. Then you have tuning, order tuning, entropy. Now, these lines represent the actual models. So when you double-click on each line, it will opens up the actual navigator that corresponds to that run. So, for example, this is my Gini card run, but this one, on the other hand, is the entropy card run. So you get to see these 2 navigators, and you get to see that they are different, and they basically explore different parts of your predictor space, and they also have different relative costs, different accuracies, and so on and so forth. And that is the purpose of the battery, is to basically organize all of those different runs in some kind of systematic process, and this way you can package everything in one big battery results grove. And by the way, the whole battery can be saved into the grove file so that you can reopen it for future use. The whole battery can be used to score data. It can be translated. And there's also other more interesting facilities that you may find useful here. The upper part here shows performance in terms of relative cost. You can also switch it in terms of ROC and look at test versus learn. And you can also sort records by the corresponding criterion, either ROC or relative cost or whatever it is that we are trying to do. So there's a very useful way to study and analyze what happens with your models, especially when you have a lot of models. Sometimes batteries can have hundreds or perhaps even thousands of runs. So those are all very useful to study and look at. The Contents tab here shows just the general description of each tree or model when it's not card, say TreeNet in the battery container. Accuracy here shows just this, what you see as a relative cost It essentially represents percent correct associated with each tree in either focus class or other classes. And here you can also see which accuracies you want to focus on, or whether you want to look at the average accuracy. Again, this is not a very interesting run because most of these splitting rules produce nearly identical trees. As we work with more elaborate batteries, you'll see that sometimes certain control parameters have profound implications in terms of accuracy. The error profiles here shows the overall relative cost in case of CART, or you can look also in the performance in terms of ROC, in terms of lift, or negative log likelihood, average log likelihood. So all of those are useful if you want to study all of these individual runs and just see how they perform and where they diverge at what model sizes and so on and so forth. And finally, we have the variable importance averaging tab that essentially summarizes for each variable that's available where in the variable importance it occurs when you look across all of the individual runs in the battery. So for example, character frequency of the dollar sign was 10% important in one run and 100% important in some other run. And this bar chart shows the different, kind of the spread of importance values. On the other hand, word frequency direct was not picked by any single run. It always had zero importance in all across the runs in the battery. And again, this is a very simple battery that has only 6 individual models. There will be other batteries when they have hundreds of runs, and that kind of variable importance summary is yet another good way to highlight which predictors are being used and which predictors are being skipped, or also the general validity across multiple predictors. So as you can see, it's relatively straightforward to run batteries, and when you go to battery tab, I want you to start looking at all of those available batteries and perhaps give it a try. Now some of them, at about half of all of the batteries are very straightforward as long as you understand the actual modeling engine that you're working with. So let's say if you are operating with TreeNet, you can manipulate a certain number of specific controls in TreeNet, and it is very likely that there will be a battery that allows you to systematically change those controls as you do your runs. Same goes for CART, same goes for Mars, but there will also be some batteries that require very specific attention. They're either big or too powerful, or in some cases somewhat confusing, and the purpose of most of the follow-up videos to this entire series on CART automation will be dedicated to explaining some of the intricacies and powerful uses of those more advanced batteries. But feel free to give it a try, to run it, ask support on how to use the battery. You may even find something that may not be working the way you wanted it to work, so we're always listening to suggestions, recommendations. The automation topic is quite fascinating. There's a lot of opportunity out there, and it's very important for you to let us know what are the other things that you would like to have available, or improved, or simplified, or redesigned. So welcome to the amazing world of SPM automation and batteries, and hope you'll have a lot of fun and also good luck.